Thank you. Uh, this is my second opportunity where I'm speaking to everybody in this website and YouTube channel. Uh, I have been given 30 minutes, and I will try to be brief. Uh, please ask me for any explanations during the question hour. See, the title is actually a twist. You see, farming the rain. Usually we have heard of rain-fed farming. I believe we have got it wrong. You should not do rain-fed farming. You should do according to the rain. And that is going to be what I'm going to talk to you for the next 30 minutes. And I have been learning this for over 4 decades. And I will also share my experience of both research as well as farming on how to do this, farming of the rain. This is a brief thing about me. I am a farmer myself. I live in a village in a low rainfall area. Along with that, I also do research. I lead the IIS, Indian Institute of Science Research Station, as well as do consulting. And my area of interest is how to do profitable farming in a sustainable way. This is what I have been working on. I failed for a long time. Recently, I have achieved some success. This is what I'm going to share with you. In the next 30 minutes, this is more like a content sheet. Here is what I would be talking to you. You see, the theme is that how do you reduce risk in farming? Why are people so afraid of farming? Why don't people get into farming like they get into business? It is simply because there is high risk in farming. If it is clear you invest 1,000 rupees and after 1 year you can get out 5,000 rupees, then there is no risk. We are sure of the return of 5,000 after 1 year. Here the risk is you may get 500 or you may get 8,000. Okay, if you invest 1,000 today. And this risk of losing money is what prevents us from doing farming. And a common sense solution to reduce risk is whatever you cannot manage, you adapt to it, you adjust to it. So that becomes the controlling variable. That becomes what defines your entire strategy, what you cannot adapt. Now, what we cannot adapt, what we cannot control, not adapt, strike out adapt. What we cannot control is rainfall. Also, the climate in general, particularly rainfall. Rain is something which we cannot control. But when I say it, it sounds so much common sense to you. Most of us, but we don't practice it. Okay. For example, please all of you, any of you who are farmers who are listening to this, please remember, if you know the rainfall of your region, you know the rainfall pattern, and whether you have adjusted your cropping pattern, what you are growing according to the rain. When I examined it, I knew I had not adjusted my cropping pattern. I grow groundnut. The groundnut is harvested usually in October. October is the time where I get highest rainfall. Because of this high rainfall, my crop always gets wet and it is difficult to harvest. You see, then why do I harvest in October? Then I keep blaming the rain. Why does it rain? Okay. Then I sow in July. July is a month of low rainfall in my region. I will be showing the data to you later on. Then why do I do the sowing in July? First week, when the rainfall is low. So like this, we do things the way we want without understanding the rainfall of my region. And then you start blaming the rainfall. What can you do other than blaming the rainfall? Okay, and that will not help anyway. thing to do is to understand the rainfall pattern of our region. For this data is available. I'll be showing it later on, and adjust your farming practices according to the rain. So this is what we mean. What you cannot control, you have to adapt. Now, in agriculture, you can control your irrigation. You can control the fertility of the soil. You can also manage the soil to some extent. Your labor can be managed. Your investment can be managed. What cannot be managed is only the rainfall and the climate and other climate parameters. So this is the primary variable or the independent variable for which all of us have to adjust to it. And so this is what I was going to elaborate upon next. Now, please, moment I talk of rainfall, all of you automatically think of the water component of the rainfall. How much does it affect in terms of soil water? The rain, of course, is important for soil water to provide water for the crops, but it has multiple impacts. How much it rains affects your groundwater, which is very deep soil. Rain and groundwater are very, very intricately connected. So we often forget the link between groundwater, which supplies to your borewells, and rain. The second thing, rain also affects your pest and disease incidence. Most of the pests and diseases, particularly fungal diseases, which thrive in high rainfall or high humidity, as well as several of the pests, they depend on either a wet spell or a dry spell. Dry spell is where there is no rain. Okay. So these are also extremely important for rain. And because of the rain events, a particular pest or a particular pathogen, which is a disease-causing organism, can become an epidemic. Once it becomes an epidemic, then it is very difficult to control. Even if you spray 2-3 times, it is difficult to control because there is so much of population built up in the air or in the ecology, it is difficult to control. So rain also has a lot of impacts beyond providing water to crops. So this is in terms of pest and diseases as well as groundwater. We should keep those impact of rain in mind. Then how do you understand rainfall in our region? The rain varies from year to year. So how do I understand it? It is so variable. For that, we in India are blessed. We have 100 years of everyday rainfall data. We can do the analysis of this data, 100 years of everyday rainfall. And based on that, it is possible to get a very good understanding of rainfall of your region. I have attempted it for my region and I would be talking about it. Now, once you understand rain of your particular region, when I say you could probably take about 5 to 10 taluks or blocks as one region. So for that region, what is it that we know? What is it that we need to do after understanding the rain? You have to define what is a good event for the crop. See, our interest is crops. You can take groundnut, you can take pigeon pea, or you can take mango crop. Mango is a tree crop. So take any of these crops as an example. You can define what is a good event for the crop or the tree, or what is a bad event for the crop or the tree. What is a good rain event? What is a bad rain event? Okay. So for example, groundnut, a bad rain event is that during harvest, if there is a lot of rain, where produce gets rotten, that is a bad event. What is a good event? During the pod filling stage of groundnut, between 60 to 80 days, if there is a lot of rain, then that is good because the pods get filled very well, the yield increases. So for each crop, depending on the phenology, depending on the life growth stage of the crop, you can define what is a good event and you can also define what is a bad event. Okay. And for each region, you will have to define those good and bad events. And I can work with you based on data to define what is the chance of good events occurring in your region? What is the chance of bad events occurring in your region? As I said, the good event and bad event depends upon the crop or the tree that you grow. So based on that, I can give you the chance of events occurring. Now, what is the work that we need to do? The work that we need to do as farmers is that you have to decrease, avoid good events and increase bad events by looking at either the planting date or the choice of the crop itself. So we can change things so that we have low risk and we have high chance of good events. So this is the understanding of what I mean by farming the rain. And here I use rain as an example. The same thing will apply to temperature. For example, there are parts where high temperature will damage your crop. So, or low temperature will damage your crop in parts of North India. So whether it is rain or temperature or humidity, they are all interlinked. For example, if there is a high rainfall, the temperature comes down, humidity increases. If there is a low rainfall, the reverse happens. So they're interrelated to each other, and you can define the good event and bad events for your crop or tree, and then work on the chance of that occurring. After you get this chance, it is possible to enhance good events and decrease bad events. So this is the work we need to do as farmers for each region. Each region, as I said earlier, each region is about 5 to 10 taluks or blocks. So this was about looking at rainfall. The next thing is looking at groundwater. Water is very, very closely connected to the rainfall. So you can see in low rainfall years or during summer months, the groundwater decreases. This happens very much in hard rock aquifers, like most of South India, most of peninsular India, Gujarat, as well as Northeast. These are hard rock aquifers. In this, there is a very close link between groundwater and rainfall. So how do we use groundwater carefully depending upon the rainfall? For that, we have a suggestion of using sensors. So this is something which has already been used so that your borewells won't run dry. So that I will talk about. The next thing is, again, how do we do smart irrigation using high technology? So these are few things which are solutions that are possible. I will be talking about that. Now let me look at this graph. This shows you that the rainfall is different in different parts of India. This is like the contour map. This is the rainfall contour map. This is where I am presenting. I am in the 75 centimeter per year contour. This is the region, and this is the rest of India. I spoke about farming the rain. That means you adapt and adjust to the rainfall or temperature or humidity of your region and do the crops or trees appropriately. Now, if you do this, what is possible? I want to show you examples of my work of what is possible. Please take a look at these photographs and see what is possible. It has taken 7 years to do this in a completely rain-fed system where there is no irrigation. The rainfall is about 60 centimeters. We started the lands like this. This was the year 0. In the middle, it became like this. It became like this. And in the end, at 60 centimeters rainfall, which is less than Bangalore rainfall, we got a crop like this. Okay. And this was done in 3,000 acres using some grant money. And this is definitely possible if you are able to adjust to the rainfall, but in a smart way, in the way that I talked about. And this is something which is possible. Let me show you another effort where we could do this transformation in 2 years. The earlier one was 7 years. This is possible in 2 years. Now, our starting point, the land was like this. In 2 years, it became like this. This is high density agroforestry. Rows of trees, in between we grow crops. In 2 years, the trees can grow as tall as this. They grew up to 20 feet in 2 years. And this is the thickness of the girth. Look at the stem thickness. These are multiple species of trees. And this is one example of tree growth. This was done in 60 acres where close to 10,000 timber trees and 2 lakh non-timber trees grew. And this is definitely possible if you follow this methodology the way I spoke about. Now, at the center of this is, as I said, in order to do what I have shown, there is some amount of science that is required. Here is the science part of this. Please look at the x-axis here. These are 13-day intervals of 13 days, calendar year. And what you see here, the graph, is the average rainfall of the region, of my region. You can see during September and October, we have the highest rainfall. The peak rainfall is in September, October. Then we also in May, in the month of May, we get. In May and July, we get rain. And after October, the rain stops. So this is the average rainfall of my region. Okay. And now here, the crops have to be fitted to this kind of a rainfall. So how to do that? How do you fit the crops? When do you start a crop? When do you end the crop? Has to be adjusted to the average rainfall of this region. So we have to go deeper than that by understanding more aspects of the rainfall, which I will take you through. Now, all of this is data from 1900 to 2000, 100 years everyday rainfall data. You can see most of the rainfall most of the time we get rainfall between 30 to 50 centimeters. So 30 to 50 centimeters, about 50% of the years, we get this much of rainfall. So what is the chance of the rainfall is given in the table. The pie chart also applies this. Okay. The minimum rainfall is 10 centimeters. The maximum is 70 centimeters. Okay. So this is the rainfall during the crop growing season. Similarly, in the x-axis, we give Ashwini. These are rain nakshatras. They are translated into calendar days. Ashwini, for example, just hold on. Meeting. So Ashwini nakshatra starts from April 14th. And then the biggest rainfall you will see is, the highest rainfall is here in Uttara nakshatra. See here, this is Uttara nakshatra, September 13th to September 27th. Okay, this is the highest rainfall. So you can see throughout the rainy season, in different nakshatras, there are different amounts of rainfall. The highest is in Uttara. So this data is available, and the red line here shows the maximum rainfall. The green line below is the average rainfall. So most of the time it can be below average also, but most of the time it is a little bit below the average and the maximum. So this is how most of the time we get rain in each nakshatras. So these are centimeters. The y-axis is centimeters. So similarly, we can also analyze the rainfall for different quantities of rainfall. Again, the x-axis is from Ashwini nakshatra, starts from April, and this is Revati, is again next March. Sorry, December is December. So this is April to December. We have analyzed the time units as nakshatra units. because most of the farmers in the rural areas use nakshatras and they don't use calendar days. But the calendar days, they are interchangeable, nakshatras and calendar days. Now look at the blue line. The blue line says the chance of no rain. This is where you don't get any rain. And look at the brown line here, where my cursor is there. This is the chance of very high rainfall, more than 14 centimeters. So during Uttara and Hasta, Chitta, the chance is very low, but very high rain chance is also very high. So this is the most reliable rain part, Uttara, Hasta, Chitta. This is September, October. Like this, it is possible to understand the rainfall of each of our region. I have done it for mine. We can also do it for the region you are interested in. You can get in touch with me. I can work with you to do the rainfall analysis. Similarly, so these are dry spells. Dry spells is where there is no rain. Look at this blue line. This is the chance of no rain for 15 days. 15 days there is no rain. Okay, 15 days there is no rain. And here is for 25 days there is no rain. So again, you can get the chance of different duration of dry spells where there is no rain. Each month wise, we can get the chance of that. And based on that, you can plan your crops. During harvest, it should be dry so that your produce will not go. During pod filling or critical growth stages, it should not be dry. So like that, depending on the rainfall, we should be able to adjust. And that is the work we need to do once we understand what is a good event and what is a bad event. So one of the things that we have done is we have provided a mobile app. Okay, and you can get in touch with us using the mobile app. The mobile app is part of a solution that we are providing where we work with farmers to gather data in their farm. And based on that, we are able to suggest to them what should be the cropping pattern. So there is a lot of sensors that we put in their farm. For example, we put soil moisture sensors. Even though we talk of rain, what is important to the crop is actually soil moisture. So we measure soil moisture. And based on that, we ask farmers a few more questions. Based on that, we would be able to give you solutions using a mobile app. And as I said, this solution also, apart from giving you what crops to grow, we can also monitor your groundwater level in the borewell. What is the water level in the borewell? Monitoring my own borewell water level. Please see this. This is from November 2022 to March 2023. So this is the data that I have monitored. And please look at the blue line. Blue line is the water level in the borewell. See, water level in the borewell is going down. November it was high. In March, it has started going down. Okay. But whereas the pumping out, withdrawal from the borewell is increasing. As the summer approached, the water withdrawal, pumping out of the water increased in the borewell. And now the borewell pump is installed at 300 feet. And at this stage, once the water level comes close to the where the pump is installed, if it goes below where the pump is installed, the borewell will go dry. So this is a danger level. See, here is the danger level. It is approaching the depth of installation of the borewell pump. So here is where I have to be cautious that my borewell will go. The solution that we have not only gives you advice on the crop, it can also give you advice on what is happening to your borewell, when your borewell will go dry. So it is able to give that. We can also give you advice on that based on measurements. So, and this is how the mobile app works. It gives you a lot of measurements: soil moisture measurement, borewell water availability measurement, how much you are pumping, all that measurement is available. And based on that, the cropping advice can be given. I won't go into details. You see, one of the effect of the rainfall is that you can make the rain percolate into the soil. It goes deep into the soil. So as farmers, we know the surface level moisture. Up to 1 foot, we know what is the soil moisture. But the soil is present, the water is present as deep as the soil is present. Very often it can go up to 6 feet. So we have an instrument which measures soil moisture up to 6 feet. This is the instrument. This is the instrument. So up to 6 feet, the soil moisture is measured, and based on that measure, recommend irrigation, how much irrigation to give. We have found that by using this deep soil moisture measurement, if you can adjust the irrigation dosage based on the soil moisture measurement, you can save a lot of water. And also it is very beneficial to the crops because the roots will go deeper. There is a scientific concept called deficit irrigation. It is possible to follow that and make the roots go deeper. And this has a lot of benefits to the crop, particularly to the trees. All the deep-rooted crops will benefit from it. You cannot do it for shallow-rooted crops like tomato and onion. This will work only for deep-rooted crops as well as trees. So the soil moisture measurement in deep layers up to 6 feet is very critical to do deficit irrigation. So we again have a solution how to measure the soil moisture and adjust the irrigation. Irrigation can be automatically adjusted by using remote control valves. I will not go into it. If you are interested, you can get in touch with me. So there is a possibility of automating soil moisture measurement and based on remote control valves. By using remote control valves, all of this is controlled by a mobile app. You don't have to go there. And this saves up to 50% water. And this is something which is very beneficial to the farmer, as he can increase the area under irrigation by using this technique. So what is the link to the rainfall? Now, you should be able to percolate more of rain into your soil, and thereby the deep soil moisture will increase. Once the deep soil moisture increases, you can reduce irrigation and save on irrigation water, increase the area if you require it. So this is the link to this. We have solutions on how to do this. I want to end now because the half an hour is approaching. And these are some of the measurements of soil moisture done by our instruments. You can see, even though the rainfall is same, different soils have different moisture levels. Okay. So soil texture has a very important role in retaining soil moisture. That is why it is not easy to understand. You need measurements to do this. These are different soil moisture levels in my own farm. And with this, I want to close the and again reiterate what I started with. It is important to understand the rainfall of your region, and there is enough data to do it. There are enough techniques to do it. And according to that, define what is a good event and what is a bad event for the crop or tree you are growing. Once you define the crop, good event and bad event, you have to increase the good events for the crop or tree and decrease the bad events for the crop or tree by adjusting it with the climate, not just rainfall, to the entire climate. Temperature, humidity are included in it. And if you do this, we can get fantastic results and great profits. And we have done this experience, and I have shown you what is possible with my own experience. And we also have a way to work with you and provide a solution so that all of this is possible through a mobile app. It can be automated. You don't have to struggle to do all this by yourself. So this is what I wanted to share with you. Thank you very much. Now it is open for questions.
Thank you, Dr. Seshagiri, for the detailed presentation. Let me see the questions now. Okay. 1 second. Can you hear me?
Yeah, I can hear you.
Okay. There was a connection problem. Okay, I'm just trying to take out the questions from the back end.
Please.
So, what does farming the rain mean?
Yeah.
Exactly.
Yeah. Farming the rain means, you see, we usually say, I do dairy farming, I do pigeon pea farming, I do coconut farming. Okay. Now, I is you should actually understand the climate of your region and do farming according to it. So I just used farming the rain as a play of words. We always rain-fed farming. It is a word play. Instead of rain-fed farming or rain farming, I said you farm the rain itself. Okay. And because rain / temperature / humidity is something that is beyond our control. So what you cannot control, you need to adapt to it. You need to adjust to it. So that is why I was saying farm the rain and do everything according to the rainfall of your region. Okay.
Okay, that's very good. Very.
So that is the word play that I did.
Actually, very innovative. Okay. So next question, could you share specific practices and techniques that have helped your farm thrive during both rainy and dry seasons?
Yeah. For example, let me tell you this. I grow groundnut. Now, you see, in groundnut, we used to do the sowing in June. Okay. End of May and first week of June. Okay. So if you sow the groundnut, that was the common practice. That is the recommendation from the Agriculture University also. So if you do that at 60 days during August, when the peak growth, when the pod filling stage happens at 60 days, it will be in first week of August. That is the lowest rainfall region, lowest rainfall chance in my region. So if I look at rainfall data, that is the worst time for rainfall. So I used to lose the crop. So what did I do? I looked at what is a good event. That means, when do I have the highest chance of rainfall? That is September end. So the 60 days period, the pod filling stage should come at September end. For that, I should sow the crop in July end, not June first week. Okay. So I delayed the sowing by 45 days. Thereby, the pod filling stage, which requires the highest amount of water, which is very sensitive, it will have the highest amount of rainfall, chance of rainfall. So that shifting the sowing period, sowing late by months compared to what is the common practice or the recommendation from the scientists, helped me to get a very good crop. The yield increase can be 100% more. Okay. So this is one simple example. Just to give a quick example, it also, as I said, rain also affects pest and diseases. There is a pest of groundnut called leaf miner, which is a very nasty pest. However, once it increases, it comes in dry spell. When there is no rain, the pest increases, so it kills the crop. Whatever amount of pesticide you spray, it doesn't work because it is a very small insect. It exists between two layers of the upper and lower layer of the leaf. So it is so small, it tunnels inside the leaf. So you can't spray much in that. So, but a very good rainfall of 2 centimeters will kill the leaf miner, even without any pesticide spray. So again, if you, during the growth time, the peak growth, if it has high rainfall, then leaf miner will not come. Even if it comes, the rainfall is able to take care of the leaf miner pest. You don't have to do any spray. A good rain of 2 centimeters and above can naturally take care of controlling the leaf miner without any chemical spray. You see? So it not only helps growth, it also helps in pest control. So this is another thing that we found, and we actually did this. It worked out very well for us. So these are specific examples where by knowing the rainfall of my region, I am able to adjust the sowing date. I am also able to control pests without spraying. These are 2 specific examples.
Okay. Next question is, how does rainforest harvesting contribute to sustainable agriculture, and what can agriculture students learn from your experiences?
Yeah. Okay. First is, see, rainwater harvesting is very central to sustainable agriculture. Any sustainable agriculture plot or a farm should have zero runoff. Okay. And it should also have zero evaporation. Everything should be transpiration, not evaporation. Okay. And the zero runoff means even when there is torrential rain, made in such a way that it is able to percolate all the water inside. Okay. So this is very central to the sustainable agriculture, because during dry spells where there is no irrigation, where there is no rain and when there is no irrigation, the deep soil moisture can act as a safety deposit. During that time, it is able to supply water and sustain your crop or tree. So it is very central to the sustainable agriculture. Sustainable agriculture also means you should have low carbon footprint. So this is the best way to have low carbon footprint. Okay. So I will not talk more about it. So that is how it is very critical. Now, agriculture students should, first thing they should do is, if they are agriculture students, they should try to practice agriculture, not learn everything from books. Okay. Please get some practical experience of what happens when you apply your theory to reality. So you should always relate to reality, practicals. So I have studied agriculture. When I did farming, a lot of things that I learned in the college was applicable. It was somewhat applicable, but many things were not true also. So you need to do a reality check for the theoretical knowledge that you have learned in the college. So that is what I think agriculture students should learn. So go by experience and reality, go by experiments and data, not from the theoretical knowledge.
Okay. And again, related to rainwater harvesting, what are the most effective techniques for rainwater harvesting in agriculture?
Yeah. You see, 2 things. These are, okay, I can tell you a few things. One is, it depends on the slope. Up to 10 degrees slope, if it is less than 10 degrees, sorry, 10% slope, if it is less than 10%, then your field bunds itself will take care. Field bunds and good practices of bunding and broad bed furrows will take care. If the slope is more than 10%, then you will have to have other structures like check dams, nala bunds, gully plugs, all that you will need in a slope more than 10%. So what is the best method? It depends upon the slope. Most of the agricultural lands are less than 10%. There are places where it can be more than 10% slope. There you will have to have additional structures. Again, it also depends upon what kind of soil you have. If it is high in clay content, your practices are different. If it is high in sand content, your practices are different. Okay. It also depends upon how much rainfall you have. If you are in Western Ghats, you get more than 300 centimeters. You know, you don't need water conservation. You need the water to get out. Okay. So it also depends upon the rainfall. If you are in the dry zone, semi-arid parts, you get less than 100 centimeters. Then, you know, your conservation practices are very different. So while I can say something general, the specific answers will depend upon which agroclimatic region are you from, okay, and what is the slope in your plot. So these answers are context specific. I can give some general answer, but unless you ask a very specific question, I can't get more detailed than this. Yeah.
Okay. Next question. Yeah, can you discuss economic benefits of rainwater harvesting for farmers in terms of increased crop yield and sustainability?
Yeah, sure. One is today, it is a no-brainer actually. Okay. I assume all of you are in India, and in India, under NREG, the Rural Employment Guarantee Scheme, soil and water conservation can be done in your own farm free of cost. The government will pay the labor. So essentially the cost is free. If you have your farm, then please get it done under the Rural Employment Guarantee Scheme. It is free of cost and you will get a lot of benefit. Okay, that is number one. So the benefit depends upon, as I said, the context. For example, let us say you are in a semi-arid zone with less than 100 centimeters of rainfall per year. So there, your crop yield will definitely increase by 30% if you do the rainwater conservation. Because please remember, along with rainwater, you are also conserving nutrients. A lot of the nutrients we apply are chemicals today. A lot of it is fertilizers. All of it is, along with rainwater, the nutrients also are going away. So you are also doing nutrient conservation and soil conservation along with water conservation. So the benefits, I would say, is easily a minimum of 30% if you do it well. And in a dry spell, in a dry year, there are many years, 2-3 years, there will be continuously no rain. There, I think the benefits are 100%. You know, if you have done good rainwater conservation, for example, I remember between 2002 to 2005, they were continuously El Nino years. They were low rainfall years. And there, a lot of trees also died. Now, in such area, during bad years, it will protect all your trees and deep-rooted crops like castor. So in such years, the benefit of rainwater conservation would be 100%.
Okay. And next question is, how can small-scale farmers implement rainwater harvesting methods on their farms, even with limited resources?
Yeah, good question. In fact, rainwater harvesting is very, very easy for small. Okay. When I say small farmers, so one of the easiest thing is there is a method called broad bed furrow. If he can contact me, I will send him the videos and also instruments how to do it. You do a raised bed every 4 feet and you sow the crop on the raised bed. So in the furrow between two raised beds, lot of water gets stored. Now, if you follow raised bed farming, there will almost be zero runoff. Nothing will go out of your farm. Everything will get conserved. So that's a very easy method. Using tractor in 1 acre by spending 1,000 rupees, you can create this raised bed. So it is quite low cost and it will stay for the entire cropping season. And that is a very good method. And you can also do weeding using the same instrument. I can give more details offline if he contacts me. So that is one raised bed furrows is one good method of cost-effective water conservation, which small farm, everybody can follow. They're not just small farms. It's very cost-effective.
Okay. And how can we utilize crop selection to best utilize the monsoon season?
Yeah. You see this, I want a good question. In fact, I can show you this based on my experience. Yeah. You are able to see this graph. You see, now, please pay attention to this. See, this is groundnut crop. You can see it starts in June, ends in October. You see this groundnut crop? So it is not using the entire rainfall. It is using only one part of the rainfall. You see? Whereas you look at below, you look at things like pigeon pea, look at castor, they use the entire monsoon. And you look at the dotted lines. You see, can you see the dotted lines instead of the solid lines? See, they are intercrops. So you can use the entire monsoon not by a single crop, by following a cropping system where you grow a lot of intercrops. You do a mixed cropping, and the tradition at least 20 crops in 1 acre. You know, please remember I am saying 20 crops. Each crop is of different duration. It can be like green gram, which is 90 days. It can also be castor, which stays for 340 days. Okay. Pigeon pea also stays for 280 days. So these are long duration crops, short duration crops. If you mix all of them, then such a mixed crop will use the entire monsoon season rainfall. Okay. And they will definitely bring higher profits and avoid risk. So that is the way to use the entire monsoon thing. Again, this is a general answer. If you are interested, you have to get in touch with me. I will be able to work for your particular region, your soil and your rainfall, and suggest something that is appropriate. Okay. This is just a general answer. We have to get specific to your region where your farm is located. I will be happy to do that.
Okay. Yeah. Next question is, how can farmers mitigate the impact of unpredictable weather patterns on crop yields?
Yeah. You see, there is no way you can do it. And this is the topic of my talk today. You see, in the entire tropics, there is no scientist, there is no atmospheric scientist who can predict rainfall beyond 5 days. Beyond 5 days, nobody can tell you how much is going to rain. The scientist's guess is as good as your guess, as good as my guess. Okay. So nobody can tell you. It is a scientific impossibility beyond 5 days. So now what can you do in such regions? So predicting rainfall is not possible beyond 5 days. So how can you adjust to something that nobody has an answer to? Okay. So what you have to do is, you have to look at past experience, that is 100 years experience, 100 years data you should look at. And based on that, you should work out probabilities, chance of things happening. And you should be able to adjust your crop to such chance. That is what I spoke of, good events and bad events. If we had pigeon pea in his mind as a crop, you can define good events for pigeon pea, you can define bad events for pigeon pea, and adjust the crop to suit the climate events. Please remember, you cannot adjust the climate. Okay, you have to adjust your crop to the climate. Okay, and that's what we need to do. Okay, yeah.
Okay.
That is what is possible.
Next question is related to the same thing. What are some proven methods for managing water stress during prolonged dry spells?
Yeah, sure. There are, okay. So one thing is, you again, as I said, these, I can give you a very general answer, but you must ask specifically with respect to which crop are we talking about. Otherwise, these answers will not be very useful to you. For example, one proven method is that you do mulching. Okay, mulching need not be through plastic. It can even be dust mulching. If you cultivate before a dry spell, then the dust mulching will be effective. Mulching works extremely well. Okay, plastic mulching, mulching by using vegetation, all of that works very well. Okay, so even dust mulching by cultivation works well. This was a traditional practice. The other methods are, in certain crops, you can probably look at anti-transpirants. Okay, kaolinite is one anti-transpirant, but that has to be a deep-rooted crop. You can't try it for shallow-rooted crops. So anti-transpirants have been tried. Then the other methods are commonsensical, like during a dry spell, if you have conserved your moisture, for example, if you use broadbed furrow, and I have used broadbed furrows, and when there is a good rainfall, so much of percolation happens that when there is no rainfall for 25-30 days also, the deep soil moisture is able to sustain. So conservation of rainfall, percolation of rainfall and increasing the deep soil moisture during good rainfall events will help you to tide over whenever it is dry spell. It can even happen between years. The last year's rainfall will be available this year during the dry spell. So it can come from previous year also. It need not be the same year rainfall. Deep soil percolation is the key to manage.
Okay. And how do you recommend managing pest and disease control without relying heavily on chemical inputs?
Yeah, very nice question. So this is at the heart of what I said. You see, of course, the easiest thing is you can always say, you can use organic methods, you can use Panchagavya, you can use Trimurti tonic, there are many, or you can use neem spray. All of that is possible. But this is like curative method. After the problem comes, you try to prevent it. And in my own experience, once there is a congenial condition, the congenial climatic condition, for example, if the humidity becomes 80% and it is drizzling all the time, even if I spray the best of chemicals, organic, natural chemicals, organic, the Ticca disease, late leaf spot, Ticca disease in groundnut can never be controlled because the fungal spores multiply in geometric proportions. The fungal spore doubles every 15 minutes. So with that kind of an epidemic, whatever you do, the late Ticca cannot be controlled. So One is there are certain organic chemicals that are available like neem, other Trimurti tonic, Panchagavya, all that is available. But you see, that is partly one way to do it. I recommend a better way. The better way is adjusting to your climate. See, if you are growing groundnut, let us say, see what is a bad event for groundnut. For example, late tikka is a bad event for groundnut. Now, you should plant the crop in such a way that during the harvest, when late tikka comes, there is a very low chance of high rainfall. Okay, the high rainfall does not come, humidity will not increase. Then the late tikka chance is very less. That is the best way to do it. So, to put it technically, you tailor the crop or you adjust the crop to suit the of your region. And as I said repeatedly, the data on climatic conditions on your region is available in India. Not many other countries have it. You don't have it in US. You don't have it in Europe. You have it in India. Okay, because Britishers have recorded it every day. So this is available in India. Please use this to adjust your crops, the good events and bad events, to the climate of this region. Okay, and that is the way to do it. If you do that, then it is a better option than using just even organic chemicals. Okay, so you have to do both, adjust the crop or the tree, and then use organic control methods, then it will work well. So that is my answer to the question.
Okay. So I'll now take up the last question.
Yeah.
What are the essential steps for implementing sustainable watershed management in rain-fed regions?
Yeah. So first is know the rainfall of your region, know the soil of your region, okay, know the slopes, okay. And today, today available and we have WhatsApp available. So it must be easy. If you don't know, if you can work with me using these tools, Google Earth and WhatsApp, we can work together and we can actually go beyond the general suggestions. See, whatever I tell you, if you Google, they will be available to you. So I am not helping you in any way better than what Google can do already, isn't it? So if you want a beyond Google kind of a help or support, then you have to work with me to get you. So, but I will just give a kind of a Google kind of an answer. So one is what is the most effective watershed management depends upon the context. The word watershed is used for a very large area. You know, it is like at least 1,000 hectares. So if the person has his farm in mind, then many of the watershed principles will not apply because his own farm is likely to be 10 acres or 30 acres and definitely not 1,000 hectares, which is 2,500 acres. So watershed is a very large spatial area. Okay, so I think he means his own farm water level management. So his own farm water level management, what is the runoff that is available? How much is the runoff that is available? So based on that runoff, rainfall, soil water structure, for a typical farm of 5 acres or 50 acres, we can devise the soil water, the water conservation methods. When you conserve water, as I said, soil gets automatically conserved. So they have to be devised for a farm. It will depend, it has to be done carefully because he is also has to grow crops there. So the water conservation measures should not trouble the growing of the crops. Okay. So it has to be adjusted and done in an intelligent way. As I said today, given the tools like Google Earth, which has a 10-meter resolution today, and the WhatsApp, which is available, you can send videos, and it is possible to design something for their farm, but that has to be designed in a very context-specific way, in a very careful way. And what is applied for the watershed will not apply for the farm. which is between 5 to 50 acres in size. So you have to be careful.
Okay. Okay, Mr. Seshagiri Rao, I don't see any more questions from participants. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for a very detailed and interesting presentation and answering all the questions in depth. And we also like to thank all the participants for joining this meeting. The meeting will now be closed.
Thank you.
You're most welcome, sir. Thank you.
Thank you. Can I talk to you for 2 minutes?
Sure, I'll just end this and I'll call you back.
Yeah.